Formulation of a general transportation problem. Today I am going to discuss how to formulate a general transportation problem. I have taken 3 by 5 transportation problem. 3 means the number of factories or sources are 3, and 5 indicates, in this case 1, 2, 3, 4, 5 are the destinations or marketplaces. Here X represents the decision variable. Decision means how much quantity you have to shift from source to destination. Say x13. What is x13? X13 will represent that from source 1 or factory 1, this quantity, x13 quantity, will be shifted to destination 3. In this one, x34 means what? That means from source or factory 3, destination 4, this quantity will be shifted. In this way, the decision variables, the quantities to be shifted, are represented by x. And this is C11, C12, C35, all these are represented the transportation cost. Transportation cost, this indicates from source 1, destination 1, shifting cost will be rupees 3C11 per unit. This is, say, this one, shifting cost or transportation cost per unit to shift from source to for destination 4 will be C24 per unit transportation cost. In this way, the transportation cost are mentioned by C. And A1, A2, A3, these are the available quantity. A1 represents the quantity available for factory A, A2 represents the quantity available for factory 2, and this is quantity available for factory 3. And these are the requirements. B1 is the requirements for destination 1, B3 represents for destination 3, in this way B5 represents for destination 5. Now, how will form the equations? It is a case of minimization, because transportation is a minimization problem, because we have to minimize the total transportation cost. What will be the total transportation cost? This is per unit transportation cost C11, and X11 is the quantity shifting from source A to destination 1. That's why this is the transportation cost for this cell. In this way, if you add for all the cells, then we will get this expression. So this is the total transportation cost. So this one, this means X34 into C34, because per unit transportation cost is this quantity is being shifted. So this is the total transportation cost, which is to be minimized. That's why the objective function is minimize z is equal to this, and subject to these are the constraint, is limitations. For first, this plus this plus this, condition will be is equal to A1. That's why this A1. For this factory, this plus this plus this, we have to find out what will be the value. Will be is equal to A2, and for this it will be is equal to 3. Now, if we write the constraint for destination, then you will see x11 plus x21 plus x31 will be a b1, and if you add all this, then it will be b2, and for last one it will be how much? It will be b5. In this way, you will see there are 8 constraints. 8 constraints by source 3 and destination 5, and for each source you will get one constraint or equation. In this way, for all requirements also you will get one equation. And another constant, x1 greater than is equal to 0, all these are the non-negativity constraints, because the decision variable cannot be negative. This is quantity, you are shifting this quantity from this source to this destination. It may be 0 or positive. Negative is not possible, quantity cannot be negative. That's why this is called non-negativity constraints. You have to solve it. You can see, this is a linear programming problem, because all the constants, you can see the power is 1, linearly related. All expressions or equations are linearly related. There is no square, no cubic in this way. And the objective function also, the decision variables are linearly related. That's why this is the linear programming problem. Hence, transportation problem is a linear programming problem. If you generalize it, then this can be represented in this form. This is for objective function, where I represents the number of sources. If we take m number of sources and n number of destinations, then this can be written in this way. If you break this, then you can see that these will be same. And these are the constraint. This is for the, it means I want, this is the sources or factories for A1, A2, A3. A1 means first factory, second factory. You can write in general way this expression, and this is for destinations. And for all non-negativity constants, you can write it this way. As this is a linear programming problem, then one question may appear to your mind that this should be solved by simplex method. Then why we are solving it by the basic feasible solution, not test on the rule, matrix like that, and optimized by MODI? Why not simplex technique is being used here to solve a transportation problem? The question is, the answer for this is, you see, all the constraints are is equal to 4, and we have seen in the case of solving linear programming problem, if the constraint is in the form of is equal to, for each constraint you have to bring one artificial variable, and it is very difficult and lengthy. It will be very difficult and lengthy to remove all the artificial variables. A special method and a special process should be adopted, and in that case the process will be very lengthy. And for that reason, to avoid that lengthy process, we have developed this technique to solving any transportation problem in 2 steps. First step, finding the initial basic feasible solution by northwest corner rule, matrix minimum method, or Bevel's approximation method, any method. And second step is to optimize it by MODI. And it will be very easy to solve in that way, not simplex method. That's why we generally use not simplex method, but only the initial basic feasible solution and MODI. Thank you. If you have any questions, please write it to the comment box. Definitely will get a reply. Thank you. And if you have any suggestion for discussion of any future topic, then you will please mention it. Thank you.